Hello everyone, this is Mohammed Yaqub, and today's video is going to be about UART or serial communication of the STM board. This is in fact an updated version for the video I created about a year ago. So in today's video I'm going to show you how to do this with CubeMX in the first part, and then towards the end of the video we will set the project up from scratch without the help of CubeMX. The second part is particularly useful for students who want to learn more about the low level of the STM board. UART has got two lines, TX and RX, that you have to cross-connect between the two devices. So you connect TX of the first device to RX of the second device, and vice versa. And you also must have a common ground between the two devices. Okay, I think that's enough introduction, so let's make a start. Let's open CubeMX and select New Project. And we've got to choose the right board, STM32F4 in my case. VGT, this one, and that's the one. And on here, the first thing we've got to do is to scroll down to we find UART, and we've got to enable one of the UART lines. We're going to use UART2 at this case, and select asynchronous mode. And thus enable PA2 as a TX line and PA3 as an RX line. And that's how we enable UART. I'm also going to enable a couple of LEDs. I might use them. Now let's go to the configuration window, UART2, and here we can set the baud rate. I'm going to leave it the same, and I'm also going to enable a DMA for the RX line. So receiving via DMA is the most effective way. You can receive using the polling method, but you'd have to wait and have a timeout, wait for the data to arrive. But with DMA, they will happen as an event, so whenever you receive a data, they will be stored and received via the DMA. You don't have to have a timeout. Receiving data can come at any time. It's not a deterministic process, so that's why I prefer to use DMA for it. So we enable DMA for the RX line, and we're ready now, so click OK, and that's everything we need to do. So we're ready to generate the code. Click on this icon and give the project a name. I'm going to call it UART video. I'm going to store it at this location and select the right IDE, MDK ARMv5, and hit OK. Now once the source code is generated, hit on Open Project. And on Keil Macrovision, expand the project folder and expand application user and open the main. And you can see the main. CubeMX generated all the low-level files for us, and now all we've got to do is to start transmitting or receiving via UART. So in my case today, I've got a TTL2 converter that connects the output of my STM board UART to the PC via USB. So I connect TX and RX to these lines and a common ground, and connect this to my PC, and it will act as a serial COM port. So you will need one of those. Okay, now let me do a very quick transmit test. There's a function called UART transmit. This function takes a couple of parameters, UART handle type diff, which is HUART2, as defined by CubeMX at the top here. It's just the UART handle type diff. And the second parameter is the data buffer, so I need to define a data buffer here as a character array. I'm going to call it TX data, let's say 30, and I'm going to send just hello world with a new line. So I've got to pass this as a parameter to the function, but I would need to typecast it to unsigned integer rate, because the function expects an unsigned integer rate variable or a pointer. And the size is the length of that string. You can do this with the string length function in the string library that I would need to include first. So include string.h. And now I can use a string length to calculate the length of that thing. And then I would need to pass the last parameter as the timeout. I'm going to give it 10 milliseconds of a timeout. And that's all. I'm going to put a delay of half a second. And that's everything. So I'm going to compile the code, load it to the board, connect this via that TTL2 converter to my PC, and open a terminal, real terminal in my case, and I expect hello world to be streamed every half a second. So let me first compile the code. Perfect, compiled successfully without any errors. Now let me load it to the board. And now I'm going to open my terminal, real term at this case, and go to port, and should be COM port 9, another company, Celab Preser, whatever, and click change. You must have the right baud rate first, so baud rate was this as I set it in CubeMX, and hit change. And now when I reset my STM board, I expect hello world to appear in here. Right, very good. Okay, now let me show you how to receive data via UART. As I said, we're going to do this with DMA. And what you need to do is you need to call in a function at the start called hello receive and then DMA. Yep. Takes few parameters. The first one is the UART handle type diff as usual. And the next parameter is an RX buffer. So I'm going to define an RX buffer here, RX data I'll call it. I'm going to give it size of 30 maximum. And I need to typecast it to unsigned integerate pointer. And I'm receiving 10 bytes at a time. So whenever I receive a full 10 bytes, it will interrupt and jump into a certain callback that I'm going to define in a minute. That's all parameters for this function, I believe, unless there's something I missed. So what this is saying, oh no, sorry, this is 8, not 16. Right. And now let me define the receive callback function, and you can find it in the functions tab and UART. So and UART.c, and it should be a function called receive complete callback, and that's the one, RX complete callback. This function is defined as weak in here, but we need to redefine it in the main without that weak object. So I'm going to redefine down here in begin number 4, and in here, whenever I receive full 10 bytes, I'm going to echo them back to the transmitter. Let me copy the transmit function from the top, and I'm going to transmit the RX data that I received, not TX1. It's undefined here because I define it locally in the main. Let me define it globally, the RX buffer only. So I need to define this outside the main to become a global variable, and then it will be seen by the callback function. So in here will be good, and now should have been gone now. Alright, perfect. So now I'm ready. So let me compile the code. Okay, we haven't got any errors. Now let's load it to the board and do a quick test. Right, let's go back to real term. So on here, I'm going to open that board again. So click open, same board rate. I'm going to clear the window. Now when I reset my STM board, and when I send 10 bytes of data, let's say hello, this is 5, and then MOH, this is 678 with the carriage return. These are 2 more bytes. Now when I send them, I expect to receive them back. Right, superb. I'm going to enable the half duplex mode just so that you can differentiate between what I send and what I receive. So the thing I send will appear in green, and the thing I receive will appear in yellow. So I'm sending this one, don't receive anymore. Oh yeah, sorry. I think this has got to do with the DMA not being circular, so maybe I did forget that in my CubeMX, but it's not too late, I can still change it in here. So let me go back to my project. So MSP, file, scroll down in here. Here are the DMA settings. The mode is apparently in the normal, exactly, just like what I expected. And this should be circular, so when you right click, go to the definition. Okay, so you can see here, so I'm going to change it to the circular mode instead. Now it should work, so let me compile it again, and load back again to the board. And now let's test again. So the port apparently is still open. Get back to the send, restart my STM board, I send this, I get it back, I send it again, I get it back. Perfect, that was good. Alright, cool. I've just shown you how to use UART of the STM32 Discovery board with the help of CubeMX. And if that's all you're looking for, you may stop the video here, but I'm going to carry on. I'm going to show you how to do the same thing without CubeMX. And to do this without CubeMX, click on Project and New Microvision Project, and select a location to store your files in. I'm going to store them here. I'm going to call my project UART no cube and click Save. And now we need to select the board, STM32F4 VGT. So that's the one, and click OK. And here we need to enable the software components that we're going to use. So first, SimSys core, and go to Device and enable the Startup. And Cube Framework API, we need to enable the classic one. And this requires other softwares that we can enable by just hitting Resolve. Now expand STM32 hull, Cube hull, and I need to enable UART software component, which is this one, and the DMA as well. And that's all I need to enable, so click OK. As you can see, Keil Microvision generated those library files, but I need to include the main manually. So right click, add a new item as a C file, and we must call it main, and click OK. And on my empty main, I first need to include the HAL library header files. So include STM32F4 xxhal.h. And now I need to define the main function, so int main, parameters void, no parameters. I need to define the infinite while loop at the bottom here. And at the very start of the main, so got practice to call the HAL init function, so HAL initialization, and the function is called HAL init. Okay, so for my peripherals, what I need to do is I need to enable pin 2, PA2 and PA3 and set them to UART mode, because they're the pins for TX and RX. And I also need to configure my UART and enable the DMA device. And I'm going to do these in two separate functions. The first one is just for UART, so UART config for the pins and for the UART configuration. And the second one is for DMA setup, so I'm just going to call it DMA config. And the parameter is void, it doesn't take any parameters. Okay, and in the definition of the first function, the UART config, the first thing I'm going to do is to enable the clocks. So port A clock and UART2 clock, using these two functions. And now I'm going to set up my pins, PA2 and PA3, set them to UART. And to do this, I need to define a GPIO init type diff to initialize those pins. I'm going to call it my UART diff. I know it's not the best name. And we use this type diff to configure the pins. So my UART diff dot pin is going to so GPIO pin 2 and GPIO pin 3. And I'm going to set the mode to alternate function, because this one is not analog nor digital input and output, so we have to use the alternate function. And then we don't have no blobs and the speed is very high. And next we're going to set the alternate function to the sortable alternate function multiplexer. So alternate GPIO AF, and we can look at the alternate function mapping of the STM32F4. You can just Google this, and you can see alternate function number 7 is the one that connects UART. So it's AF7 to start off with, and it's UART1. Sorry, it's UART2 for PA2 and PA3. So that's what we need to set on the alternate. And now finally I need to call GPIO init function to implement those initialization, implement them on port A, and I can pass init type diff in this case. And I need to pass a pointer to it. And that's all for the pin configurations. And now we need to configure the UART peripherals, so configure things like the baud rate and other settings. And first I need to define a UART handle type diff, but I need to define it globally because we're going to use it in the main. And I called it my UART handle. And we use this to set up the UART peripheral. So UART.instance to UART2, so this is just to select the UART instance, and this needs to be UART with an S. And then we do some initialization. So the first one perhaps is the baud rate, and I'm going to set this to 115/200. And then the mode to TX and RX, so UART mode to TX and RX. And now some other initialization. So word length to 8 bits, so 1 byte, and stop bits to just a single one, and oversampling to 16. Now we need to call HAL UART init to implement those initialization, and we pass a pointer to the UART handle, and that's all. And one final thing I want to do here is, it's not quite related to UART, is to enable the SysTick interrupt. So we need to enable a SysTick interrupt to be able to use HAL delay in our main. So I'm going to do it in here. And I would also need to define the SysTick handler out here to link the system SysTick handler to the HAL library SysTick IRQ handler. This is usually defined by CubeMX in a separate file, but we've got to do it manually ourselves here. Alright, and now let's configure our DMA. So DMA UART config, and the first thing to do at this function is to enable DMA1 clock, because DMA1 is the one that connects from UART to the system, or to the RAM memory to be very specific. And to be able to configure the DMA, we need to define a DMA handle type diff, and I'm going to define it globally again, and I called it my DMA UART2 handle, and we're going to use it to set up our DMA. So perhaps the first thing is so DMA.instance, and it's going to be DMA1 stream 5. And the reason for this is that when you look at DIMM-A1 map of the STM board, you can just Google this, you will find this table. You can see that DIMM-A1 stream 5 is the one that connects to UART2RX, so that's the one we need to use. And next we're going to do some initialization, and I think we should start with the channel, which is also defined in the table that we just looked at. So let's go back to the table, and the DIMM-A channel is channel 4 that connects to stream 5, so UART2. So DIMM-A channel and it's 4. And now we're going to do a series of initializations, so setting the direction to peripheral to memory, disabling peripheral increment address, but we are incrementing the memory address, peripheral data alignment to byte, same for the memory, and the mode to circular, the one we made a mistake in CubeMX part, so we ensure that it's circular here, and a priority to low, FIFO mode to disable. And if you think I'm going too fast, don't worry, I'm going to include the main.c file in my description of the video. And now we need to call HAL DIMM-A init function to implement those initializations, and we need to pass the DIMM-A handle type diff and a pointer to that. And next we need to link our DIMM-A to our UART peripheral. So the first parameter is a pointer to the UART handle type diff, and the second parameter is HDMA-RX because it's an RX line, and then the third parameter is the DIMM-A handle type diff. And finally we need to enable DIMM-A stream 5 interrupt using these two functions. And we also need to define a similar thing to what we did with the SysTick interrupt. So we define the SysTick handler. We also need to DIMM-A1 stream 5 handler as well outside of the function here. So DIMM-A stream 5 just to link the RQ handler to the HAL library handler. Alright, that's all here, so let's scroll up and write the main code. So in the main we need to call in the functions that we defined. So I need to call in UART config and DIMM-A config to implement their configurations. And yeah, now we are at the same stage as the project generated by CubeMX. I'm now going to include the other parts that we did in CubeMX. I'm just going to copy and paste them here very quickly. So the first one is to define a TX and RX buffer, and then transmit the TX data every half a second. We also need to include the string library at the top to be able to use string length function, so I'm going to include it in here. And that's it for the UART transmit. So we're going to test the transmit in its own, and then we're going to come back and finish off the code for the receive. So first let's compile it and make sure that we don't have any errors. Okay, I have one error, and I think I know why it is. It says undefined symbol DIMM-A config. I think definition of the, yeah, that's the one. So definition of DIMM-A config, I did DIMM-A UART config, and that should be DIMM-A config. Now let me compile it again. Right, superb, error is gone. Now let's load it to the board and test in real time. Alright, okay, that's another one. It doesn't upload successfully because we need to select the right debugger. CubeMX was setting this up for us, but now we have to do it manually. So go to options for target and go to debug, and in here select ST-Link debugger, and also go to settings and go to the trace window and enable trace, and set the core clock to 16 MHz and click OK. Now it should load fine. So hit the load button again. Perfect. So let's go to real term. And on real term we need to select the right port. I think it's port 9, and the right baud rate 115200, and click change. And now when I reset my STM board, I expect the string to be streamed here. Alright, very good. And now for the receive functions, I'm going to do the changes very quick here. So I need to comment the transmit one because I don't want to transmit anymore in here. And I need to start the DIMM-A receiving 10 bytes of data, and the RX complete callback at the bottom. So here's the one. So whenever I receive 10 bytes, I'm going to send them back. And this should be the right, the newly named UART handle. Just copy this from CubeMX one. Okay, so let's compile the code. Okay, no errors. Load it to the board and back to real term. Okay, and on real term, open that port again, and we're going to clear the window. I'm also going to enable half duplex so that I can see the data I send in green color and the data I receive in yellow. So let's go to send, and the STM board is expecting 10 bytes, so I'm going to say the same one, hello Mo. with the carriage return 2 extra bytes. So when I send this, I expect the data to be returned back, but I first need to reset my STM board. Okay, so I send this and I get it back. Perfect. And again. Alright, that's good. And that's how to set up a UART project for the STM board without the help of CubeMX. And this brings me to the end of my tutorial today. Thanks for watching, and as always, if you found this helpful, don't forget to hit like and subscribe. Thanks, and I'll see you next time. Bye.